Hello student, welcome to my channel Concept Clear by Eskemaji. Today we will discuss about distance time graph and velocity time graph of describing motion. Watch the video till the end to clear your concept. First of all, DT graph of a stationary body. DT graph of a stationary body. The body which is at rest. Stationary body means the body which is at rest. In x-axis time and in y-axis distance. The body is at stationary, that means it is rest. At 0 time, it is distance covered is equal to 0 or 5 or 10. In 5 seconds, same. In 10 seconds, it is also same. In 15 seconds, it is also same. That means the line will be parallel to time axis. The body is at rest. It is a stationary body. But DT graph of a body which is in uniform speed, uniform velocity, then time in x-axis and distance in y-axis. Distance means displacement. Gradually distance increases. That means in 0 time, in 5 time, in 10 time, in 15 time, in 20 time. 0 time, 10 time, 15 time, 20 time. Then it gives a straight line. Straight line means body is uniform motion. Speed will be uniform, velocity will be uniform. This is DT graph of a body with uniform velocity. And velocity will be, what will be the velocity? Velocity will be slope of the line. Slope of the line means tangent, tan theta. Inclination, positive inclination is theta, tan theta. That means perpendicular by base. Perpendicular by base. Velocity is equal to slope of the line, and in distance time graph, slope of the line represent perpendicular by base. That means AB, OB. That means AB by OB. This will be the velocity. Slope of a DT graph, important point. Slope of a DT graph represent velocity. How to calculate velocity? Velocity representation can be calculated by perpendicular by base, not displacement by time. From the graph, you have to calculate perpendicular by base. But in VT graph, velocity time graph, VT graph, a body which is in uniform velocity a body which is in uniform velocity, the graph will be parallel to x-axis, means time axis. This is the graph of body with uniform velocity. Body with uniform velocity. But a body which is at uniform acceleration, that will be represented just like this. Gradually velocity increases, v1, v2, v3, velocity increases. That means graph will be in t1 time velocity v1, in t2 time velocity v2, in t3 time velocity t3, v3. Therefore, line will be straight to this. Therefore, in velocity time graph, the straight line represents the body is in uniform acceleration, not in uniform velocity. Acceleration, how to calculate acceleration? Same, acceleration is equal to perpendicular by base. That means acceleration, slope of a body is, slope of a body represents acceleration. This is VT graph of a body with uniform acceleration. If the body is in retarding motion, then uniform retardation can be represented thus. This is time and this is velocity. Initial velocity was maximum and final velocity is minimum. This is retarding velocity. Retardation will be same, perpendicular by base. If a body starts with uniform velocity and gradually increases its velocity uniformly, then it can be represented in such a way. Suppose the body is at initially u, initial point u, and after some time it increases its velocity and finally becomes to v. Therefore, it can be represented thus. This is uniform velocity and this is uniform acceleration. If a body moves just like this, initially 0, after some time up to v, then uniform velocity, not uniform acceleration, finally uniform retardation. Uniform, non-uniform can be determined by the nature of the line. If the nature of the line is straight, then it is uniform. If the nature of the line is curved, then it is not uniform. Understand? How to calculate area, how to calculate displacement. Displacement can be calculated by calculating the area of the graph covered, area of the line enclosed with time axis with axes. Understand? Suppose in this case, what will be displacement? Displacement will be area of this rectangle and area of this triangle, or area of this trapezium. In this case, this portion is uniform acceleration and area of this triangle will be the displacement. In this case, this to this is uniform velocity, and finally it retarded, uniformly retarded. That means this area will be the smallest displacement. Total displacement, area of this trapezium. Total displacement will be area of this trapezium. This video will help you to calculate the graphical problems related to describing motion. Okay, thank you. Stay connected.